In this video, let us have a look at work energy and power. So we are going to go around the concepts surrounding energy conservation. So here is the question that we are going to start with. So figure below shows a stone of mass 2 kg, which drops from the top of a cliff and takes 2 seconds to strike the ground. Acceleration of free fall is equals to 10 meters per second. We can collect the data so that we do not go back to the statement reading over and over. So we have mass of 2 kg. Then we have time of 2 seconds. That is the time it took to strike the ground. Then we have acceleration due to gravity, which is 10 meters per second square. Then the first question is, as you can see the cliff. So this is the cliff or the height, okay, or the top of the building, unfinished building. You can look at that in this, you can look at it in that way. The first question is that, name the form of energy possessed by the stone before it falls. So where it is there before it falls, where it is seated there, you know that is called gravitational potential energy. So to answer question A, we are going to say gravitational potential energy. So gravitational potential energy is just potential energy due to height. Okay, there's height involved there. So that is the question. That is the answer. Determine the height of the cliff. So how are you going to determine the height of the cliff? With what you are given. You are given the mass, the time, and also acceleration due to gravity. Okay, or acceleration of free fall. So now, since you are given acceleration of free fall, you can look at the formulas. Okay, which one are we going to use? You find that we are going to use this one. X is equals to ut plus half at square. Now, or g, since we are looking at gravity there. So now, initial is 0. So if initial is 0 multiplied by time, this whole thing is going to be 0. So which means we are remaining with x is equals to that one. Now, since we are calculating height, you know that x is distance. In this case, we are talking of vertical height, vertical distance. So it's just going to be h is equals to half gt square. So in most cases, if you're asked to calculate the height, that is one of the formula that you apply. So let us apply it. Okay, so let us apply it. We are going to just down here. So the height is going to be half, what is gravity? That is 10. Then time is 2 square. So what are we going to have? This and that will cancel, remain with 5. Then height is going to be 5 multiplied by 2 square is 4. So 5 multiplied by 4, which is just a 20. It is in meter. So 20 meter. That is the height. Then C, calculate the kinetic energy of a stone when it is halfway down. Now this is where you need to know the concept of energy conservation. And what does it state? Energy can neither be created nor destroyed, but only conveyed from one form to the other. In this case, since you are dealing with a conversion of energy or interconversion from kinetic energy, so we are dealing with the potential energy and kinetic energy. Potential energy is the stored energy or the energy due to the position of the object, but kinetic energy is the energy of the body in motion. So now one thing that you should know is that on top of the cliff here, all the energy is in form of potential energy. And how do you calculate potential energy? Mass times gravity times height. So all the energy is in form of potential energy. On top there, kinetic energy is equals to 0. So let us calculate the potential energy there on top. Mass we are given is 2, multiplied by gravity is 10, multiplied by height we found is 20. If we are to multiply this, will give us 400. Energy is measured in joule. So energy there on top is 400 joule. Now when the stone here start falling, going down, it has entered the motion. As a result, potential energy will start converting to kinetic energy. Remember the conservation? So it doesn't convert at once, but it is something that happens as it is moving. So now take note, as it is falling, the speed also is increasing. Speed is direct proportional to kinetic energy. So which means the potential energy is being converted to kinetic energy. The concept that you need to know that when it reaches the midpoint, half of is falling. The height is what? 20. So when it reaches 10 and 10 down, in terms of height, potential energy becomes equal to kinetic energy. By the way, as you go down, potential energy is decreasing. but kinetic energy is increasing. So halfway of its falling, you have potential energy is equals to kinetic energy. Okay, that is something that you should know. Now, since we have on top there as total energy 400, we are just going to divide it into 2, which means we have 200, 200. To find kinetic energy, we are just going to say 200 joule. But of course, all these calculations were supposed to be here, looking at the marks that it has. So you are supposed to start by calculating the potential energy. Then of course you say potential energy, all the energy on top is in form of potential energy. As it falls halfway of its falling, or halfway of the cliff, potential energy is equals to kinetic energy. Therefore, 200 is the kinetic energy halfway of its falling. Then find the velocity of the stone as it strikes the ground. Now, sometimes you are going to find these questions that immediately before it strikes the ground. So as this stone moves coming down here, its velocity continue increasing. And the stone has maximum velocity before it reaches the ground. Immediately before it hits the ground. And at that particular point, all the potential energy has been converted to kinetic energy, which means potential energy is equals to 0. Then kinetic energy has turned into what? 4,000 joule. So on top there, potential energy is equals to 400. But immediately before it strikes the ground, all the potential energy has been converted to kinetic energy, and kinetic energy is equals to what? 400. And this is the assumption that is going to help you to calculate the velocity. How are you going to work it out? So you're going to say, you're going to use the formula for kinetic energy. Kinetic energy is equals to half mass times velocity square. We are going to replace the kinetic energy since we know that it's 400 at bottom here. So 400 is equals to half, what is the mass? The mass is 2. Is it 2? Yes, the mass is 2. And the mass, please, is supposed to be in kg. Then velocity square. So 2 and 2 cancels. You are remaining with 400 equal to v square. Introduce the square root, introduce the square root. And therefore v is equals to, that is plus or minus 20. So we're going to put 20 meter per second. So that is the velocity we are looking for. Otherwise, that is how you answer it. Okay? Then for a second question, figure B4.1, below is a diagram showing a stone of mass 2 kg that was pushed up a slope. So we have a stone of 2 kg that was pushed up the slope. Then take note of this information. 72 joule of work was done in moving the stone up the slope with from Q to R. So 72 joule was used to move this one through this part. What is the potential energy of the stone at R? Now look at this one. We cannot calculate potential energy to say mass times gravity times height. We do not have the height. We do not have gravity. You can say, okay, we are on Earth is 10, but where are we going to find the height? Now listen very carefully. When you are given such a question, you need to make an assumption. Look at this. Potential energy, we said, is the stored form of energy. So the energy stored in this one is called potential energy. The work done to lift this stone up to the top there is equals to its work done. So at this point, where air resistance is neglected, work done is equals to potential energy. And therefore, potential energy is equals to 72 joule. Very important. Then if a stone falls through RT, which is this part, what would its potential energy be at S? So S is halfway of falling. Remember what I explained from the previous part? So potential energy is equals to kinetic energy. On top there, all the energy is in form of potential energy, so which means is equals to 72 joule. And kinetic energy is equals to 0 since the object or the stone is not moving. So as it start falling, halfway of its falling, you just divide this one by 2, so it will be 36. Okay, so there it is 36 joule. Then calculate the height of TR. This TR, how are we going to find it? So to calculate the height of TR, we are going to need the formula that has height in it. And in this case, since we have potential energy, we can use potential energy is equals to mass times gravity times height. So we have height. potential energy on top there, we're going to use the whole potential energy since the whole height. So 72 is equals to mass is 2 multiplied by gravity is 10 on earth multiplied by height. So it's going to be 72 is equals to 20 h. So 20 20, and this one h is going to be, what is our height? Should be able to give us let me just punch on the calculator, 3.6 or something. So 72 divide 20, it is giving me 3.6. so 3.6 meter. That is the answer to this question. Okay, then the velocity of the stone just before it strikes the ground. You see what I said? Sometimes you might be told just before it strikes the ground, what is its velocity. So before it strikes the ground, we are going to say that all the energy has been converted to what? All the energy has been converted to kinetic energy. So kinetic energy is equals to half mv square. So kinetic energy is equals to 72 equal to half, the mass is 2, then v square. So we have v square is equals to 72. Introduce the square root, and therefore v is going to give us 8.5 meter per second as the velocity. Okay, and sometimes the question might come, find the maximum velocity. So that is how we simply find the maximum velocity, because the maximum velocity, or the stone has maximum velocity right here before it strikes the ground. Like I said, as it starts falling, even its velocity start increasing, and the maximum velocity is at the bottom there. So when you're asked of the maximum velocity, it's just the same as the velocity before it strikes the ground. Let us have a look at this question. It was on section C, where you get to choose questions. So it was C1. Figure C1.1 shows a conveyor belt driven by an electric motor carrying a suitcase into a trailer of a truck, as you can see the diagram. The first question is that give two differences between mass and weight. Okay, I have forgotten where we are coming from. We should have given the differences between mass and weight. So mass and weight, one of the differences is that mass is constant everywhere, whereas weight is varies from place to place. And normally we compare the moon and the earth. The other difference that we can talk of is in terms of their units of measurement. That is, mass is measured in kilogram, or the SI unit of mass is kilogram, whereas that of weight is in Newton. The other one that we can talk of is in terms of their instrument of measurement. That is, mass is measured using the beam balance, whereas weight is measured using the spring balance. Also, you can talk of their definition. Mass is just a quantity of matter or amount of matter in a substance, whereas weight is just a pull of gravity on an object. Those are the differences that you give between mass and weight. So get to pick two from that if at all you're asked the question. Then for B question, if the suitcase of mass 20 kg is lifted from the ground to a truck, taking gravity as 10 Newton per kg, find the weight of the suitcase. So weight is equals to mass times gravity. We are going to say mass is 20 multiplied by, let's say 20 kg multiplied by 10 Newton per kg. And this one is going to give us 200 Newton. Okay, kg and kg cancels. Then for a second question is that the gravitational potential energy of the suitcase at the top of the conveyor belt. So gravitational potential energy is equals to mass times gravity times height. What is the mass? Is 20 kg multiplied by what is the gravity? 10 Newton per kg. So it's just the same as multiply weight multiplied by height, then multiply by what is the height. The height here, we pick the vertical distance and not this one. So the height is right here, which is 6. So multiply by 6 meter. It has to be in meter. If you multiply these, you should be able to find 1,200 Joule. Okay. Then question C. Suitcase takes 12 seconds to travel 9.0 meter along the conveyor belt. Calculate the power of the suitcase, or calculate the power of the motor. So power is equals to work over time. Now, let us find work before we even go to calculate power. So work is equals to force times distance. Now, we are told along 9. Okay, so 9 meter along this part. Okay, now what is our force? Our force is the weight of the suitcase, which is the one that we found here, 200 newtons. So we are going to say 200 newton multiplied by 9. Okay, and if we multiply 200 newton multiplied by 9, we should be able to find 1800 joule. So now we are going to say 1800 joule divide 12. Time, we are told 12 seconds. And this one is going to give us, what is it going to give us? It is going to give us 150 watts. Okay. Then the last question is that an electric motor is powered by an input voltage of this, then current of that, then calculate the electrical energy input to the motor in 12 seconds. Calculate the electrical energy input in that in 12 seconds. So energy is equals to V times I times T. Voltage times current times time. So get to finish this one. Okay? Otherwise, you've come to the end of the lesson, and see you in the next one.